Today we want to do revision on calculus. We want to do revision on calculus. Okay, we want to do revision on calculus. Of course, calculus is divided into two. We have integral and differential calculus. So we have integral and differential calculus, as we all know. But I'll be starting with the limit of a function. That is the first thing that we'll consider today. So if you want to look at revision on calculus, I'll be starting with the limit of a function. Limit of a function. That is, how do we find the limit of a function? The concept of limit of a function is one of the most important ideas of calculus. So it's one of the most important ideas of calculus. That is, if we limit a function, we can limit a function. For instance, if we have limit as x tends to a, f of x, what are we trying to say here? What we're trying to say here is that we want to find the limit when x tends to a. X tends to a does not mean x equal to a, but as x approaches a, either from the right or from the left. For instance, on the number line, we have 0 at the center. We have 0, we have 1, we have -1. So this 0, numbers from the positive side can approach 0 from the right, while number from the negative values can approach 0 from the left. So it could be from either side. So when we say limit as x tends to -2, it simply means that as x approaches -2, what will be the value? What will be the value? That's what we are trying to say. So we can see that as x gets closer and closer to a, then what are we going to get? It depends on the value of f of x. So it depends on the value of f of x. So if we have limit, there are some theorems that actually guide limits of a function. So the first one we are going to look at is the first question. When the question says evaluate limit as x tends to 5, then the function is 3x minus 7. So what do we do here? How do we evaluate this limit as x tends to 5? This simply means that as x approaches 5, closer and closer to 5, what do we get? What will be the value? We just say that this is the same thing as, of course, limits can be linear. What I'm trying to say is that I can express this, I can linearize this. I can say limit as x approaches 5, 3x minus limit as x approaches 5, 7. Of course, the right hand side does not have x, so this will be 7. So this will give us 3 into bracket 5, that is 3 times 5, minus this is 7. 3 times 5 is 15, minus 7, that was going to give us 8. So limit as x tends to 5 of this function is equal to 8. So that is how to find the limit of a function. So that's how to find the limit of a function. So if you want to find the limit of a function, that is what is expected. So that is what is expected. If you want to find the limit of a function. Another example is when we have the limit of a function in form of fraction. If we have it in form of fraction, what do we do when we have the limit? For instance, let's say example 2. When we have something like limit as x tends to 2, when we have x minus 2 all over x squared minus 4. So when we have limit of a function, when the function is fractional, so what do we do here? Of course, there are two approaches to this. The first one is that since we know that the denominator is difference of 2 squared, the denominator is difference of 2 squared, we might decide to express the denominator. We can first express the denominator as I'm going to do now. We express the denominator as what I'm about to do now. That is, we express this denominator. We can say this is the same thing as limit as x tends to 2, x minus 2 into bracket. This is difference of 2 squared. We have minus 2 into bracket x limit as x approaches 2 all over x plus 2. Of course, once we substitute for x equal to 2, we are going to remove that limit. The limit will be there again. That is, we are going to have 1 all over 2 plus 2, and that will be 1 all over 4. And that's what we are going to get. So we can solve it with this method, or we can solve it with this method, or I'm going to use what is called the L'Hopital rule. When we have limit of a function that is fractional, we can apply what is called, we got 1/4 here. We can apply what we call the L'Hopital rule. The L'Hopital rule simply means that you differentiate the numerator and denominator. Of course, I've not introduced differentiation, but people that had the idea about the differentiation, we know what to do. That is, we are going to differentiate the numerator and the denominator. So, of course, this will be limits as x tends to 2. When we apply L'Hopital rule, then when I differentiate this denominator, I'm going to get 1. When I differentiate this denominator, this will be 2x. So I'm going to have 1 all over. I'll substitute when x equal to 2. 2 times 2. And that will be 1/4. So when we have a limit of a function that involves, when we have the limit of a function that is fractional, then what we are expected to do is that if you can express that, if you can factorize what we are given, or we just go ahead and apply L'Hopital rule. When we apply L'Hopital rule, it simply means that we differentiate the numerator and the denominator separately. Then we substitute the value of x at that given point. That is what we are going to do. Then what if we are given the limit of a function as that x tends to infinity? The first two example, x tends to a particular value. What if we are given the limit of a function as x tends to infinity? What are we expected to do? This is what I'm trying to say. If you are given the limit of a function, let's say example 3, as x tends to infinity, if you are given something like this, as x tends to infinity, and we have 4x minus 3 all over 2x plus 2. What are we going to do when we have this type of problem? So if x tends to infinity, what we are required to do is that we divide through by the highest degree of x that is given. That is, I'm going to divide through. In this case now, the highest degree of x in this question is just x raised to power 1. So I'm going to divide through by, I will divide through by x. That is, I'm going to have, in this case now, I'm going to have limit as x tends to infinity. I will have 4x divided by x minus 3 divided by x all over 2x divided by x plus 2 divided by x. So where we have, of course, x will cancel x here. X will cancel x here. So wherever we have x at the denominator, that one will vanish. When the x tends to infinity, 3 divided by infinity simply means it could be 1,000, 10,000, 1 million. If you use 3 to divide infinity here, it's going to vanish. It will be around 0.00. So all this will vanish. At the end of the day, we'll be left with 4 all over 2. And the answer is going to be 2. In this particular question, the answer will be 2. So when we have limits as x tends to infinity, then that is what we are going to have. Then I'm going to take the last example. Example 4 under limit. Example 4 under limit. So when x tends to infinity, what are you expected to do? That is, when x tends to infinity, and you have this type of question, 7x squared minus 2x plus 1 all over 3x squared plus 8x plus 5. In this case now, the highest degree of x is 2. So I'm going to divide through by x squared. I will divide this entity by x squared. That is, x tends to infinity. I'm going to divide through by x squared. 7x squared all over x squared minus 2x all over x squared plus 1 all over x squared all over 3x squared all over x squared plus 8x all over x squared plus 5 all over x squared. I will do the cancellation. This will cancel this. This will cancel this. This will reduce this to 1. This will reduce this to 1. Then wherever we have x or x squared at the denominator, everything will vanish to 0. Because x tends to infinity. Infinity simply means is undefined. It will be 1 billion, 1 trillion. So when we divide larger number, when we use smaller number to divide larger number, it's approximately 0. So all this will vanish to 0. Everything that I have here will vanish to 0. At the end of the day, I'll be left with 7 all over 3. That will be 2 whole number, 1 all over 3. That will be the limit of that function. So if you have to find the limit of a function, that is what we are expected to do. And of course, there are some theorems that actually guide the limit of a function. There are some theorems that guide the limit of a function. That is, if you have two functions, a and b. If you have two functions, a and b, and if you are required to find it simply means that you just separate it. When it is addition, this is what you are going to have. This is what I'm trying to say. If you have limits, limit of a function, then you are just expected. If you have limit of a function, don't just bother yourself. Just go ahead and add limit as x tends to, let's say, A. If you have f of x, there are two functions here, and f and g, and you say you have g of x. So if you have limit of a function, if the limit, this is what I'm trying to say, that is, let's say the limit s tends to A, f of s is equal to capital F, and the limit as x tends to A, g of s is equal to capital G. So the addition of these two limits, the addition of these two limits will just give us f plus g. The subtraction will be f minus g. Then the multiplication, when we have limit as x tends to A, f of x multiplied by g of x. This is multiplication. Will just be f multiplied by g. Then the division is still the same thing. The limit as x tends to A, when we have f of x divided by g of x, will just be f divided by g. In this case, provided that g must not be equal to 0. We have to be very careful. This is the first one. This is generalization of limit of a function. So if the denominator is equal to 0, that function, the limit of that function will be undefined. So we must note that. Before we generalize the limit of a function. So if you want to find the limit of a function, that is what we expected to do. And recall that when we have a L'Hopital rule, simply means you differentiate both the numerator and the denominator. So I'll go ahead and introduce differentiation now. Differentiation. So what is differentiation? Of course, calculus is divided into two. We have the integral calculus and we have the differential calculus. So calculus is divided into two. We have the integral calculus and we have the differential calculus. So the differential calculus is otherwise known as differentiation, while the integral calculus is otherwise known as integration. So what is differentiation? The process of finding the derivative of a function is called differentiation. That is, if you want to find the derivative of if you want to find the derivative of a function, you are simply saying that you want to differentiate that function. That is the differentiation. The process of finding the derivative of the function. So if you have y to be a function of x, okay? So if you want to find slight change in x all over slight change in y, that is derivative of x all over derivative of y. What you are trying to say is that you want to differentiate this function. Then we talk about dy dx simply means f prime of x. So that f of x could be any function. We have so many functions. It could be polynomial function, transcendent function. We have exponential function. We have logarithmic function. We have so many functions. It can be a parabola. That function can actually be. The function can be any function. But let's just assume that function to be f of x. So it now depends on the function that we are talking about. If you have that function to be y to be f of x, which is the function of x, the differentiation of that function, which is dy dx, that's the simple meaning. That's the simple meaning. This simply means dy all over dx. Dy all over dx. It simply means slight change in x in y all over slight change in x. Then that's the y dx is otherwise known as f prime of x. That will be the first derivative. And we can have as many as possible derivative. If I go ahead and look for the second derivative, it will be d square y all over dx squared. That will be f prime of x. That's what we are going to get. So we can have it up to the nth derivative. This can continue up to the nth derivative. So we can have something like the ny all over the xn. Then that's the same thing as fn of x. That's the meaning of that. That is the nth derivative. So when we have the derivative of a function, we have to be very careful. We start from the first one. That's the first derivative. We can talk about second derivative. We can talk about third derivative up to the nth derivative. So how do we find the derivative of a function? That is the question. Because we have defined differentiation as the process of finding the derivative of a function. That's the meaning of differentiation. If y is a function of x, what I'm trying to say about function, you can check my videos on special functions. This function that we're talking about here can be maybe 2x squared plus 3x plus 4. If this is the function, this is a polynomial function. Okay? This function can be equal to sine x, or we say sec square x. This is trigonometric function. Y is a function of x. We are trying to define the type of function that we have. This function can be exponential sine x. Of course, this is exponential function that involves trig function, or we can have it to be e raised by 2x. These are exponential function. Y is a function of x. The function can also be log e x, which is the same thing as in x. So this logarithm function, logarithmic function, it's possible to also have that type of function. We have so many functions. So when we say y is a function of x, that function of x could be any function. Could be transcendent function. Could be a parabola function. We have so many functions. Just note that when we say y is a function of x, your mind should just just check my videos on special functions. We have so many functions. Okay? We have so many functions. Y is a function of x could be any of these functions. So I want to be specific now. I want to be specific. So if you want to differentiate a particular function, there's what we call differentiation from the first principle. Differentiation from the first principle. Of course, if the examination we are preparing for is not multiple choice, it's not CBT, that is the one you are going to use computer to answer, ABC, multiple choice question that has different, no, when you have multiple choice question, you can have A, B, C, you understand? If the examination you are preparing for is not multiple choice, of course, what I'm about to discuss now is very important, because that is the basis, that is the introduction to calculus. It is called differentiation from the first principle. Differentiation from the first principle. Differentiation from the first principle. Let me say first principle. First principle. We call it differentiation. Differentiation from the first principle. If you are preparing for multiple choice question that required A, B, C, D, of course, this is not necessary, because you can just go ahead and differentiate directly. But if the examination is the one that is theoretical, that is, you'll be asked to write, then this is important. I will only pick just one or two examples under this differentiation from the first principle. The question says that find the derivative. Find the derivative of y is equal to x squared from the first principle. So look at this particular question. This is what we want to do. Of course, we can just look at this and get the answer directly. But if you want to write theoretical examination that involves theory, that will be required to analyze every process, then this differentiation from the first principle is important. You have to know this differentiation from the first principle. So if you have to differentiate from the first principle, what do we do? Now just look at the board. If you want to differentiate from the first principle, it's very simple. In this case now is y equal to x squared. So how do I differentiate this from the first principle? That is what we are asked to do. So how do I do that? Just look at the board. What you are going to do is that wherever you have y, you are going to add the y, delta y to it. That is the first step from the first principle. That is the first step you are going to do. So where you have y, you add delta y to it. Where you have x, you have delta x to it. So now make delta y the subject formula. Of course, that simply means that you are going to subtract minus x from both sides. That's the implication. You subtract minus y. So if I do that, I'm going to have x plus delta x all squared minus y. And what is y from the question? X squared. What is y? Y is equal to x squared. So I'm going to change this, or let me say s. Then I'll go ahead and expand this expansion now. Of course, this is just S2. If it is cube, we can use that Pascal triangle. You can check my videos on binomial expansion. If it is s plus delta s all cube or quarks raised to power 4, you can use what we call Pascal triangle to know the coefficient of the expansion, or you use the combinatorial analysis combination method to do the expansion. But in this case, it's very simple. It's just squared. Just say this will be s squared plus, there will be 2 here, 2x delta x, then plus delta x all squared delta x all squared. That's the expression for this. Minus, what is y? Y is s squared minus s squared. Of course, s squared can take care of s squared here. Just look at s squared can take care of s squared. Then we go to the next. Okay, let me just continue from here. From there, I'll just continue. That delta y is equal to, what we have left is 2x delta x plus delta x all squared. Because s squared has taken care of that minus s squared. So we are good to go. So from this stage now, we divide through by delta x. Divide each entity by delta x. Delta x. We are differentiating from the first principle here. That's why I'm following this step. If you are to differentiate from the first principle, you must follow all these steps. So this will take care of this. This will reduce this to 1. So that we have delta y all over delta x to be equal to 2x plus delta x. Then what is dy dx? Dy dx in the real sense simply means, we've talked about limit function. What we are going to do here is that we now limit. You limit as delta x now tends to 0. That is, as delta x approaches 0. Our dy delta x all over delta x simply means what we have here, 2x plus as delta x approaches, it moves closer and closer to 0. Simply means we are going to change delta x to 0 plus 0. At the end of the day, our dy dx is the same thing as limit as delta x tends to 0, delta y all over delta x, which is equal to 2x. So that simply means that if we differentiate y, which is s squared, our dy dx from the first principle will be 2x. And if even we can do that, we can do this directly. So that is the answer that we are going to get. So that is how to differentiate from the first principle. That is how to differentiate from the first principle. Okay? That's how to differentiate from the first principle. So if what we have here is sine, is, let's say, a strict function, still the same thing. If the exponential function, just follow the step. Where you have y, add delta y to it. Where you have x, you add delta x to it. Then divide delta y at the left hand side by delta x. You divide through. Where you divide through, you do some I will call it arithmetic, or you do some manipulations. Then at the end of the day, you now limit as delta x tends to 0, which will give us the y ds, slight changing y over slight change ds, and that's what we're actually looking for. So that is that. That is how to differentiate from the first principle. But what I'm trying to say is that if you have multiple choice question and nobody asks you to differentiate from the first principle, then differentiation from the first principle is not necessary, because I can actually get this directly from the principle of differentiation. So if we are not asked to differentiate from the first principle, then we can go ahead and get this. We can go ahead and get our result without any stress. That is what I'm trying to say, is that if y, this is the normal way of differentiation now. If y is a function of x and which is equal to s squared, that is, we have y to be equal to s squared. If I'm to differentiate this now, I'll just go ahead. I won't waste my time. The y dx here will just be the power that we have here. You bring it down and subtract 1 from this. That is 2x 2 minus 1. That is the normal way of differentiating. Bring the power down here. Use it to multiply what you have. Subtract 1 from this. At the end of the day, I will have 2. 2 minus 1 is 1. S raised power. That will be 2x. That's how to differentiate. So if you have to differentiate, just go straight and get your answer. You don't need to go through the first principle. We went through the first principle because the question says differentiate from the first principle. And in general, if y is equal to s raised power n, when we have polynomial function, if y is equal to s raised power n, then dy dx will be n x n minus 1. That's what we are going to have. That's how to differentiate. If y is s raised power n, if you want to differentiate that, then the n will come down. N will be s into bracket n minus 1. That is what we are going to get. That is the normal way to differentiate a polynomial function. So let's take another example. This is how to differentiate the polynomial function. So we'll be taking the function one after the other. So we are going to be taking the function one after the other. Let's take another example. Say example 2, where we have find the derivative of, we have to differentiate y is equal to s cubed plus 3s squared plus 4x plus 5. Okay? Look at this now. How do I differentiate this? Of course, this is a polynomial function. I will say dy dx is equal to, this 3 will come down. I will have 3 S raised to power 3 minus 1. That's what we are going to get. Plus, I have 3 here. This will come down. I will have 2 times 3. S raised to power 2 minus 1. Then plus 4. Here now, this is 4. We have x. There's 1 here. 1 will come down. Then we have 1 minus 1. 1 minus 1 will be 0. Anything raised to power 0 is 1. So here will be 1. Plus, differentiation of its constant is 0. So whenever you have constant, when you differentiate the constant, the differentiation of a constant is 0. Note, the differentiation of a constant is 0. So we note that. So from here, we are going to have 3s squared, because 3 minus 1 is 2, plus 3 times 2 is 6. We have 6. 2 minus 1, so that will be 6x. Then here will be 4. When we have x, x is 1. 1 will come down. 1 times 4 is 4. 1 minus 1 is 0. Anything raised by 0 is 1. So this is the answer. Okay? And when you have a constant, the differentiation of a constant is 0. So we should take note that the differentiation of a constant is 0. Please, let's take note. Constant is 0. So that is how to differentiate. Then there's this other one. Function of a function, or it is called function. Function of a function. It's called function of a function, or chain rule. Or you call it chain rule. So what do we mean by function of a function or chain rule? The concept of calculus is very wide. But of course, we'll try as much as possible to do the revision and do justice to that particular question. If you have problem that involves power, for instance, if you have y to be equal to 2x plus 3 raised to power 3, how do we differentiate this? If you don't want to first expand before we get to results, or say raised to power 4, how do we differentiate this? So if you have this type of question and it is multiple choice question, of course, you require multiple choice question requires short answers, and we will not be given the whole time to do it. So we are going to apply what you call function of function chain rule to be able to solve this problem. That is what I'm trying to say is that what we have inside this bracket, it is called core. We call it core. This is called core. So we are going to give that core a particular, you denote it with another letter. I can say let u equal to 2x plus 3. Now u is a function of x. I will now say du dx will now be equal to what? 2. When I differentiate, I'll get to differentiation of a constant is 0. Okay? Then what is y? If I represent everything inside this bracket as u, y become what? U raised to power 4. Isn't it? Then I'll say dy du. Now I'm differentiating y with respect to u now. When I call everything here u, I'm differentiating u with respect to x. So here will now be, this will come down 4 u, 4 minus 1, that's 3. So how do I get dy dx? Because ideally the question is y to be function of x. But since I cannot do this directly, I represent the core, what I have inside this bracket, as u, so that y is not a function of u, then u is not a function of x. That's why we call it function of a function or chain rule. Okay, dy dx will now be equal to du dx multiplied by dy du. If the u cancel the u, we are still going to get our dy dx. But since we cannot get dy dx directly, we have to use this. We have to use this method. Okay, we have to use this method. Since I cannot get that directly, I have to use this method. Then from here, what is the u dx? That is 2 multiplied by dy du, 4u cube. So here I'm going to get 8u cube. But the answer should be a function of x, not u. So what is u? U is 2x cube. So I will not change everything to 8 into bracket 2x plus 3 or cube, and that's the final answer. So in this case now, my dy dx will now be 8 into bracket 2x plus 3 all raised to power 3. Okay? So if this is a multiple choice question, you don't need to stress yourself. Just look at the question. Don't stress yourself. You don't need all this process. The short method that you're going to use is that when y is equal to 2x plus 3 raised to power 4, don't stress yourself. Okay? You don't need to stress yourself. Just bring down what you have here. This is the question though. How do I get this process? Using chain rule or function of function. Without going through all the process, just bring down what you have here. 4. Okay? Into bracket, write what you have there. 2x plus 3. Subtract 1 from this. 4 minus 1, 3. Multiply by, differentiate what you have inside. If you differentiate this, it is 2. Because differentiation of constant is 0. When you differentiate 2x, you're going to get 2. 2 times 4, 8 into bracket 2x plus 3 raised power 3. That's what you're going to get. So instead of following through the process, that's just the simple method to abbreviate that process. Bring down what you are given, subtract 1 from it, then differentiate what you have inside that bracket, use it to multiply. That will be the answer. So this is the YDS. If this is multiple choice question, objective, you don't have the whole time. You don't even need to work anything there. Just look at it and go ahead and apply the formula. So that is that about function and for function. Okay? If you have to apply function and function, this is the type of question that you apply function and function. Then because of our time today, I will stop at product rule. That is product rule. Where we have product of two functions. Product rule. It is called product rule. What I'm about to discuss is called product rule, or in some textbooks we see derivative of a product. Okay, still the same thing. That is, if we have product of two functions, for instance, let's say if y is uv, y is a function of u and v, where u is a function of x, v is also another function of x. So what is the y dx? The y dx simply means you pick you differentiate this, dv dx, plus you now come back and pick v and differentiate u, du dx. So that's what we do. And this is called product rule. If you have product of two functions, what you normally do is that you pick the first function, you differentiate the second one, plus you go back and pick the second function, you differentiate the first one. That's what we do under product rule. That's what we do. So let me just take one example under product rule. I will take one example. Then we close the class. We continue from there. StreamYard actually dealt with me today. So probably I will go live on YouTube. But going live on YouTube is not as clearer as when I make use of StreamYard. StreamYard is neater and clearer than going live on YouTube. So let's say differentiate. I say differentiate. You can say differentiate, or the question will say find the derivative. Differentiate y is equal to 2s plus 3 into bracket s squared minus 4. Look at this. We have products of two different functions. Okay? We have product of two different functions. So I'll go through the normal method. Then I'll just teach us the shorter method for multiple choice question. I will represent one as u. I'll represent the second one as v. I'll say u is equal to what? 2x plus 3. So what is the u dx? You know, u is a function of x here. Will be 2. The ratio of constant is 0. Okay. What is v? S squared minus 4. Let's say minus 4. What is the v dx? That will be x. The ratio of constant is 0. Finally, what is the y dx? Under product rule, you don't need to memorize anything. Just function u, differentiate the second one, dv dx, plus you now go back and pick v. You differentiate u, du dx. That is the idea. Then what is u? Just write u. 2x plus 3. Multiply by what is dv dx? Multiply by 2x plus what is v? S squared minus 4. Multiply by du dx. Du dx is what? 2. So if you open up here, we are going to have 4s squared plus 6x. Here we are going to have plus 2s squared minus 8. That's what we are going to get. Okay, that's what we are going to get. Then if we simplify, we are going to have 6s squared plus 6x minus 8. So that is the y dx. But if I don't want, if this is a multiple choice question that I don't have all this time, what I'm going to do is that I'll just look at the question. I won't stress myself. This is what I'm going to do. I'll just say, in my mind, I will know that this is u and this is v. So my dy ds, I can get it directly. Dy ds will be, when I pick this, 2x plus 3. I'll just differentiate this. When I differentiate this, I'm going to get 2x. Plus, I'll go back and pick this, s squared minus 4. I'll differentiate this. This is 2. Just simplify. I'm going to have 4s squared plus 6x plus 2s squared minus 8. And at the end of the day, I will have 6s squared plus 6s minus 8. which is the simple. You might decide not to write all this. Once you are familiar or you are used to this formula, and you don't need to memorize it. If y is a function of two, it's a product of two functions. Pick the first one, differentiate the second one. You come back and pick this, you differentiate this. Just simplify. You're going to get your answer. So for today, we have been able to introduce limit of a function. So I introduced differentiation. I start with differentiation for the first principle. We look at the derivative of a polynomial, how to differentiate the polynomial. We talked about function of a function. We've talked about function of a function. And lastly, we talk about product rule. Because of our time, I would love to stop here. We are going to continue from here in our next class. So I decided to go live on YouTube because the StreamYard that I normally use, the StreamYard, they have problem with their network, with their service. So hopefully by tomorrow, I think everything should be in order. And if everything is not in order, I'm going to go live on YouTube as I've done today. Thank you, and God bless you all.